So you're going to nuke the other one that we were just doing?
Yeah, I'm starting a new project. So how I install it, just for all you people watching the video at home, later, whenever this gets posted up. Let me find it real fast. NuGet. One of those days. We're going to actually install a template here. And it is going to be called, let me make sure I got it right. -I sdg.templates.web, not .react, .api. This will install the template for us to use later. You can write that down. I'll let this be up on the screen for a little bit. This will give us access to everything that we have and everything that we need. So I'm going to run this and install it. This should already be a thing for me. And after you install it, it should appear on your list right here. SDG Web API template. And in order for us to use it, net new SDG API, and we'll call this Math API. Say it's created, we're going to cd into it, Math API. We're going to run .NET Restore on it, and then that's it. So .NET Restore is like Yarn install. Goes in and installs all the dependencies and restores all the things for us. After that, we're going to open this up. Ta-da. And we should see something that we're used to, right? We have our program CS, we have our startup CS, we have our controller files.
We've got a Docker file.
We have a Docker file too. There are a few more things here as well that we're not going to explore today. But feel free to poke around if you want. But really, this looks like our other API project, right? So let's head and let's actually start doing our stuff here, because I care about my operation inside of a math. We know that we're going to be creating a new controller, new C# class, and we know that our endpoint is everything is going to live in operations, right? /API/operations/subtract 1 and 2, right? So now let's create a new endpoint, a new controller class, and let's call it operations. Operations controller. .cs. Ta-da! Here we go. Not much there, right? Nothing too crazy.
So you're setting up what you were setting up last time again, right? Like
Yes.
the controller thing.
Yep. Yep. I've created a new controller. There's a lot less here, as you notice, right? And that's okay. That means we need to go in and add a few things here.
Oh, because this isn't the value controller, this is the operation.
Yes, this is a brand new controller for us to do something about. We need to tell it a few things first off. We need to say, hey, you know what? This is a controller that inherits from a base controller that has a GET request, that has endpoints, that is part of our web API stuff.
And it has our 4 things: add, subtract,
Yes.
multiply, and divide.
So let's first off say, hey, you know what? This is inherits from controller base. Include the correct namespace. And hey, you know what? This is an API controller.
And then decorate it.
Yep, decorate it, and it lives at the route of API/controller. And let's give it one endpoint, just so we can test it out. Let's give it a get endpoint. Public. It's going to return something here. We'll We'll come back to that in a second. Get, let's call this ping. And let's return just the string pong. Just a quick ping pong endpoint. All this is doing is going to say, hey, you know what? Our API is set up and ready to go. Does that make sense? So if I hit this endpoint, I should get back the word pong. Right? So what's my return type here? A string, right? Right. It's just a string. But really, will this work? Yes, that's great. But really, what our controllers return isn't just the raw type. It's something called an action result. An action result is a fancy way of saying a JSON result, or just an HTTP response in general. So we can change its status code, we can change its some headers, we can do everything fancy with that. But really, hey, you know what? We are returning an action result that is a string. And that's it. You notice how our return type doesn't change at all. It's still returning, quote, pong, right? We're saying, hey, you know what? This is actually going to return a response object that has everything around with it that we're used to seeing. A headers, a bodies, status code, everything like that. Let's run this and see what happens. Come over here.
An action result is part of the system included stuff.
Yes, that's part of the Microsoft ASP.NET Core MVC libraries. You notice we haven't actually used system yet.
Mm-hmm.
So .NET watch should run. We'll ignore that warning for right now. It's happening at 5001. If I come over here to Postman now, can I zoom in? Yes, I can. Anyways, if I go to now, instead of going to /API/values, can I zoom in even further? Aha, there we go. Can you see that in the back, Dante? And Heather and Liv and Hector? Cool. I want to go to /API/operations and send it, and I should get back my Pong. Woohoo! It's set up correctly. I like it. I like it a lot. Next, let's create our add endpoint, unless we have thoughts. Alan?
If we did all that /ping, will it still return Pong?
So if I do /ping, do we think that this will work? Yes? No?
No,
Maybe? Why not,
probably
Joe?
not, because APIs are stupid. Sorry. Not stupid, but exact.
Just to argue with Joe,
They're-
but
Yeah.
yes, but it's not necessary yet because ping's the only thing in the operations.
So we have a yes, but not necessary. We have no because it's stupid. No real reason behind it.
I would say I don't know because I don't know anything about APIs.
Very humble answer.
See?
We got a 4 not found.
Great.
Because the route that we defined was just API/controllers with one method on it. We haven't defined ping yet. We've defined ping here, but that's the name of the method that runs the code. That's not the actual endpoint.
Does the endpoint go in the decoration part?
Yeah, the endpoint's going to go in the decoration part.
Hold on, say that part again.
The endpoint is going to go in the decoration.
Oh,
That's
okay,
where we
alright.
create the ping or whatever.
Yes. So if I wanted this to be a ping, I would actually expand the HTTP GET decorator to say, hey, you know what? This actually lives at ping.
But instead you can just extend it and say it's going to be the addition part. Is that not what we're doing next?
Eventually, yeah. You're about 5 minutes in the future. So now we're saying, hey, you know what? This method is at an endpoint. That's at API/operations
/ping.
/ping. Yeah, right? So now if I come here, I now get my 200 pong back. Now I can play ping pong with myself.
And ping can be whatever, right?
Yeah.
API table tennis.
Mm-hmm. So now let's make add. Finally, right? After an hour and a half. It's going to be another method. It's going to be another get. It's going to be at /add public, and what do we return? Public action result. We're returning a number, right? Add numbers. And this is going to have two parameters, right? And x and y. And then we're going to return x plus y. Phil?
Just out of curiosity, if you were making an online ping pong game, would you just be getting the position of the ball like every second?
Yeah,
Or like every half second? Or something?
every frame.
Every frame you would be sending a GET request?
Yeah, that's why this doesn't work for stuff like that. RESTful APIs don't work for games.
Oh, so it wouldn't be a state.
Yeah, because it would be
Because the state matters. The
'Cause-
last place you were matters.
instead of me send. So if we were playing an online ping pong game,
Mhm.
I would not send you where I am. I would send you where I'm going. So I'm going at this degrees at this speed,
Right.
and then your client would calculate the same way that my client would because of the code. And then whenever you would hit it, you would send me back the direction you hit it and everything like that. Yeah, right.
That's intense.
To get even
Create a
crazier
API.
is that usually that data is sent to a server, and then that server returns to us not like data to build the state, but like a picture of the current game state. So what we're seeing actually isn't running; it's actually just a picture of the environment that we're. It's a whole different beast. Anyways, how are we feeling here? Not quite there yet, though. Because if you recall our endpoints, we have a couple things here, right? This is our x and this is our y. Right? X, y. So now we need to define parameters inside of our URL.
Is that more decoration?
Yeah, not more decoration, we're sprucing up our decoration. We're going, hey, you know what? Add
It's the magical syntax.
squiggles. This should feel kind of familiar.
Yeah.
Yep.
Don't you need a dollar sign somewhere though if you do that?
Nope.
Because
No.
it's not string interpolation.
What?
It's not-
That
it's
seems
not
like you're
string-
breaking rules now though if you do that.
No, it's not string interpolation.
Okay.
I'm giving you just the string template or a mask of what our URL looks
So, but it knows?
like. Yeah.
Just knows, man.
Oh, that's wrong.
And so because we said x and y, those are the names of our variables, of our parameters heading in. So let's see if this works.
Let's.
So it's no longer add, it's add /4/2. What should I get back?
6.
6. Hey.
Oh.
How are we feeling right now?
Who's doing the math though?
Browser.
It's telling
The
me.
browser's doing the math?
Our servers doing, our APIs doing.
API.
Yes.
Okay. So, and your server's running on your computer, so your computer's doing the math.
Yep.
From itself.
Yeah.
Like,
Yeah, if you think about it, it's actually, we're going to have a React app that's running on a server. We're going to have our APIs running on a server. Whenever we develop, those servers are both here outside my laptop. Even though really they could be anywhere else. For development, they're here. And next week, we're going to actually make it so that they're all running on the same server. I know. Huh. How are we feeling with this?
pretty cool.
All right.
I feel like a size 10 foot has been shoved into a size 6 shoe. Like that's my brain.
Fortunately, shoes will stretch. It's gotta break in them good pups, right?
What you saying that we're gonna learn to run on the same server?
A React app and an API.
And the API are on the same. Is that how it's usually designed? That they both run on the same server?
Sometimes
Depends on the size or
on the architecture and the problem that you're solving. Sometimes it makes more sense to have your API living on a separate server and your React app living on a separate server. Sometimes it makes more sense to have your React app living inside of your API.
Can you give examples of this?
So a good example is at my old job, I worked at an insurance company. We had an API for our insurance claims and our insurance quotes. Right? That didn't have a front end. But what it did is that it had a React app on top, not a React app, a website on top of it that talked to it. That app also had a whole bunch of other things talking to it too. That website did a whole bunch of other things as well. So they were, even though it was the same system to the user, they were actually two different systems that just happened to talk a lot. That's all fine and dandy, right? I also worked on a website where the API lived on the same server as the front end. Because that API wasn't publicly available, that was just for that app. So it was just right there. And it needed to do some more transferring of like files and stuff. So they were more tightly coupled. Versus this other one over here, where they weren't tightly coupled, they didn't depend on each other, they just used each other. Well,
Yeah, I have another example also. Worked for a company that we had an app. Well, we had a large system that had APIs built into it that handled clients, costs, and everything. Each department had their own little app written to talk to that API to get what they needed. Like HR needed to track how many consultants they were sending, so there was an app written for HR. Procurement, they had to track all the costs and everything, so that as a special app written for them, they were all going to the same API, just calling things differently.
And these apps are all ORMs, right? That are talking to the API, or?
No, the API uses an ORM.
So what app? So I guess it would be like a front end app that's talking that they use for each one of those, right?
And if we have time, we'll actually probably hook up a quick React after this. I know, right? That'd be kind of cool. Kind of see it all come together. But first, we need to make 4 more endpoints, right? Subtract, multiply, divide, and modulus.
Easy.
Yeah, right?
I mean, you could use the same framework, kind of. Switch out stuff.
I could.
Change numbers.
Yeah. Just change the operation, right?
Yeah.
So HTTP get, subtract, x, y, public action results, int, subtract numbers, int x, int y, that's all fine and dandy, return x minus y. B.
How do you know? So the first is add, the second is subtract, and it's the syntax is the same up top. I'm not sure if I'm using the words correctly, but that's it. That answers it. Subtract. We got it.
You got it?
Yep.
Okay. Yeah, that is it.
Just watch you complete.
Does that make sense now? Is that okay? Cool.
Perfect.
That's all fine and dandy, but really APIs don't just return a number, right? We return objects, we return structures. JSON.
Right.
What does JSON mean again? Anyone?
Phil.
Our dictionary of programming terms, Phil.
Let somebody else take that.
Oh.
Why was it JavaScript object notation?
Because you're right.
Yeah, that's what it is.
JavaScript object notation. We're expecting the squiggles and the arrays and the keys and the values that we're used to, right?
I was channeling Phil.
I know. I never do that.
This isn't it. Right?
Because we didn't tell it to return anything.
Right, we're just telling it to return, hey, return a number. So now we want to give our return value a structure, right? What's a good structure in C# that has keys and values and properties?
JSON.
Classes.
All classes.
Right? So I'm going to create a new class that just defines the structure of my return type. Right?
It's like what we're doing with the animals.
Yeah. You created a structure for animals, right? It had species, number of times seen, and locations. That you use that structure to define how your table works, right?
Mm-hmm.
We use that exact same idea to say, hey, you know what? We're gonna have a structure for what our JSON object gives back. For what that looks like. That structure, that special kind of POCO, is actually called what's called a view model. That just says, hey, you know what? Our view will consume this structure of data. Sound good? So let's create a new class. Let's put it in a new folder. Let's call this folder. New folder. New folder? Haha. View models.
Why would I do that?
I don't know. To be completely honest, I was sad and upset, so I hit it with a hammer and it worked. I'm gonna create a new class inside of it. I'm gonna name this. Let's call this a math result.cs. So this is going to be the structure of a return result of the math result. What's one thing you notice that's different right off the bat? On line
The
one.
namespace is different.
Yeah, the namespace is different, right?
Yeah.
We now have math API.viewModels. What does that look like? The folder structure, right?
Mhm.
Best practice says that your folder structure should match your namespace. So now we have our view models. They're going to be in their own namespace. Our controllers, something that I walked over, are in their own namespace. That's how we as developers can help organize our code. Because now we have different silos, different bowls that we're cooking with. Then we can say, oh, you know what, here's our dry ingredients. I only need to include my dry ingredients in some places. Same with namespaces, I can only include my view models where I need to. So now my startup is not using my view models, right? There's no using view models here. They're agnostic, they don't care about each other. But over my controllers, I will care about that. So now whenever we get to adding it, we're gonna add a using statement at the top saying, hey, using math API dot, yes. So our results, wherever our math results are, what do we want to add here? Let's do prop int result. Yeah, sure. Prop int x, prop int y, and anything else that we want to return from this? Maybe just for science, do a string operation. Of what operation that we actually did.
Okay.
Yeah, there's not much that goes here. If you're like, what else can we add? I don't know, that's perfectly fine. View models are traditionally either very small or very big.
Oh, that's
Yeah.
kind of comforting actually.
Yeah, right? And they oftentimes will look like your models, like your database. But they'll be slightly different. Do you have a question?
Add an A after
Code spell check is the best extension. Thank you. Cool. Awesome. So now I want to use this. I'm going to head over to my operations controller. I'm going to head to my addition. And now I need to actually use that class that I just made. So I'm going to say, hey, you know what? I'm no longer returning an integer. I'm returning a math result. I'm going to get an error. What does the error say? Should seem familiar to a few of us. All right. I can click the light bulb, and it's like, hey, you know what? You got to use your view models. And it'll automatically add the view models up to my top. Ta-da! My error goes away. That's it. I knew that'd crush you. Yeah, that light bulb's really awesome.
where I stopped. I was just like,
Yeah, that's it. But now that we have that, we want to return no longer the actual thing here, right? We want to return a new math result with the properties of x is x, y equals y, result equals x plus y, and then operation equals addition.
So you're basically just complicating it so that we have more stuff to read out and read for the example of creating it, right?
Yeah, I want to look at
Like functionally it was working before, but now we're just like making it more elaborate so we can
Yeah.
have stuff to play with.
So whenever you hand it off to your front-end developer, they're like, oh, I can consume JSON. I know exactly what I'm doing, exactly what I'm returning. That designing an API contract is really useful. Because if you and I are working on a team, that's going to be the first thing that we're going to agree on is, hey, my API endpoints are going to return this JSON structure. And I can code to that. You can code to that. And then once we're both done, we should be able to come together with ideally no issues, but relatively few issues.
And so you would do this regardless of how big or small your API is. You probably do this. It's just like when we were doing the other stuff where we hard coded some information and so it had
Yep.
pop up on the screen.
Yep.
And then we'll complicate it later.
Yeah, whenever I'm in full stack mode, I tend to have split personalities. Like, okay, I'm only doing API stuff. So I'm only worrying about what's my JSON structure in, what's my JSON structure out, and that's it. Does that make sense? And then on my other side, I go in my front end brain going, oh, you know what, here's what I'm sending back, here's what I'm sending over. I'm gonna pretend that I have no control over what's going on in the back.
Oh yeah, you could.
Yeah, you could, because what that tends to do is that tends to cut back on the assumptions that I make. So whenever someone else uses my API is not as janky. Did you ever encounter a janky API?
You
Yeah.
do some changes as a front end guy that you're not allowed to really change, and then you just carry it over and make sure that you follow through on that.
Yep.
It's broken.
Yep. So let's see if this works. So I'm going to go back to add. Hey, that looks slightly better, right?
Ooh, fancy.
Hey, that looks like a JSON object that we can consume in a React app, right? So let's consume it in a React app. Why? Because we can. So I'm going to come here, clear. I'm going to create a new React app. Math client. This,
In the same directory as your API?
Yep. It doesn't matter though. This is a completely separate project. So our API doesn't know about our React app, or our React app does not know about our API. Our API can be written in C#, Golang, Ruby, JavaScript, Python, it doesn't matter. Our front end can be written in React, Vue, Vanilla, it doesn't matter as well. It's two separate projects.
Because they're both joining with JSON or whatever that
Yeah.
that means.
Because we've both agreed that, hey, you know what, we're going to be spitting out JSON, we're going to be consuming JSON. So that common interface, an API of JSON is like, hey, you know what, that's our common language. Yeah. It all comes together. I hope.
That makes a lot of sense why they wouldn't want to why you use C# for the database stuff. It's way more sharp.
I think my favorite joke is like, I think someone said it already, but why do JavaScript developers need glasses? Because they can't see sharp. I just enjoy that so much. Anyways, where are we? Code dot, here we go. So our math client, come over here. This feels good, right? Our public folder's back, our source folder's back. We're back home. I know. Do we like Axios? Better than Fetch?
Back in the land of magic.
Mm-hmm.
Axios is awesome. I will say it's very interesting to see this done in Node.js and now in C#. It's like 9 days, completely different.
Yeah, Node.js is completely different. But it's the same.
Right.
Because .NET Core is actually based off of Node.js. a little
Oh,
bit.
really?
You can definitely see a lot of patterns that are repeated in both places.
Yeah, I am noticing so.
Yarn start. Yarn starting, still going to queue up on port 3000. But here now in source, I'm going to head over to app.js. I'm going to be a naive developer and write all my code inside of app.js. And really, state equal then, and on component did mount, import Axios from Axios. And we're doing axios.get. And where am I going?
Localhost 5000.
Yep, localhost 5001 /API. And let's do operations. Operations/add. And what's someone's favorite number?
No.
42.
42. And what's someone else's favorite number?
13. That's not operations. That's you added letters and you should have taken one away.
Oh yeah. Operations. Spell check? Nope. Is that right?
Yes.
Then response, and we'll console.log. Here. This set state. Result equals rest.data. I'm going fast because this should be familiar with us. We've done this enough. And then down here, this .state.result .result. Oh.
You
Oh, I-
need to put result and state in line 4. Or data and state in line 4.
You are correct. Guess I should show you what I'm looking at, huh? Look at all these windows up. So here's our page. And there we go. It's talking to our API. It made its call right here if we check it out. Did a get to operations add. A get, we got a 200 back. And our result, that should look familiar, right? You notice that it automatically lowercase, camel cased the words for us. In our POCO class, we had capital X, capital Y, capital R results, capital R, capital O operation. And I was like, yeah, you know what? It's JSON. It's going to convert it to more JavaScript friendly notation. That's part of that controller base, that functionality that we got from inheriting it. That kind of helps massage that for us a little bit. So yeah, now we just have JSON that we can print out to our screen.
That is amazing.
How we feeling? Cool.
What was the URL that you put in there? It was localhost 14. Okay.
Yeah, the exact same one that we use in Postman, right? We're like, hey, Postman, let's do this thing for me.
That's awesome.
This might be too far ahead, but how would you, like, say you need to build an API that needs to pull up a lot of data?
Yep.
And we may talk about this later, but how would you handle that if you find that once you start putting data in your app and you're pulling from the database, it starts to get too slow and the page is loading too slow?
Mm-hmm.
So how do you handle that?
So optimization is hard because people like to do a lot of pre-optimizations and kind of guess where it is. The first step is always measure to find out where your slowness is. The second one is measure again to make sure that that's where it is.
Well, in this case, we know the slowness is based on how much data you're pulling too much data at once.
So can our query be changed? are we pulling out data that we need to that we don't need to?
No.
If we need all the data, can we paginate the data? Is that possible?
Maybe.
Is our database indexed correctly?
Right.
But really, that pagination is probably what it is. And at that point, it's now, hey, give me all cities, but also give me a page number and how many it's taking.
Right. Well, there's different ways to do that, I guess. Depending on the.
So when it's paginated, it doesn't actually request the second page until you've
Until you request a second page.
requested.
Have you ever needed to pull from one API and put information into another API?
Yes.
Pull from one API and store it in another API because you couldn't really use that API the way it was designed, and you had
Mhm.
it was better off doing your own design.
Yeah, there's a lot of times where like you'll create an API, then you like pull in data from someone else just to populate with base data, or you use a second API to supplement the data. There's a really cool final project of the last cohort, Armchair GM, where he used his actual like player data, came from another API, but he would take that data, then he'd put it in his own database in a different structure.
Right.
So,
So you could create an API to fix somebody else's structure of their API just because
Yep.
you don't like it.
yeah, that kind of idea where I'm using an API behind my API is called a proxy.
Oh.
Yeah, right? So like the weather API has a very weird convoluted data structure, right? Took you a little bit to kind of wrap your head around of what's going on. If that didn't make sense to you and that upset you enough, or that didn't fit your use cases enough, you could write a proxy in C# that says, hey, you know what? Go to this API, request the data, and then convert it to a structure I like, then return that back to my front end. So really your React app is going, hey, React, go to my API, then go out to their API, come back, and come back. So it's an extra hop, but it's getting it in a format and a structure that you like better.
And more likely you'd be putting other information in there too, because it's just natural.
How often are you actually passing your data in your URL? Because we could make this work with just add, right? We wouldn't actually need
Yeah.
numbers there. It's just we're just doing it more for the example.
Yeah, and we'll actually do it a lot, because whenever we get to like, I mean, even last week when you did the employees directory for your React project, like you were passing data inside the URL, right?
Right.
Give me this company's and this employee.
Right.
So yeah, so the resource, that's gonna happen a lot. How are we feeling?
Like I need practice.
Speaking of practice, for your homework tonight, right?
Transitions.
That's a perfect transition, and I love it. For your homework tonight, you'll be creating for me a simple API. You're actually going to take the 2 warm-ups today and create 2 endpoints. One's going to be at /API/mumble. The other's going to be at /API/explode, where I can pass that endpoint a string. It would do the operation and return me the exploded or mumbled out things. I know, right? So you get to practice the warm-up again and APIs. I know. I love it. It's a stroke of genius. Thank you. Thank you very much. Right? But really, just 2 endpoints, 2 simple gets, and that's nothing too crazy. Because I'm also signing out another capstone project. I know, right? So wireframes, near completion, right? You're feeling good with them. You kind of know what your app looks like. The next step, as with all of our projects, is to actually create the static HTML. So I'd love for you tonight to create a new app, React Stack, and start building out the HTML. Don't worry about like what data you're calling, what's dynamic. Don't worry about making things change. Just take your wireframes, start coding them up. Really, you should have like the React router, and then like a couple of components with a really big render, or a really big return if you're going to use functional components. Does that make sense? Cool.
And resumes are due to Catherine on Wednesday.
Thank you for the reminder. Right? Time management is awesome. I know we talked about some techniques week one of how to manage your time. Yeah, it's going to be critical to kind of stay on top of things next couple weeks. So here we are. Homework will be out by the end of lunch. There will be an optional with me at 3 today. I heard a couple of y'all requesting and talking. If you have any questions about the Cohens, bring them at 3 o'clock. That sound good? Cool deal. Homework will be out.